In this video, we're going to look at two free response questions having to do with limits. In this first question, we're asked to find a value of k that will make g of x continuous at x equals 2. So we have this piecewise function g of x, and the first piece is a quadratic function, the second piece is a linear function. So we know both of those functions are always continuous, and we want to make sure that this function g of x stays continuous at the switching point at 2. So if the function is going to be continuous, that means, of course, that g of 2 exists, and it does. G of 2 is equal to 2 squared minus 3 times 2, so that's negative 2. I substituted 2 into that piece because that's the piece that includes the or equal to. The other thing that has to be true for g of x to be continuous at 2 is that we have to have a limit at 2. The limit from the left must be equal to the limit from the right, and that limit must be equal to negative 2, the value of the function. So I'm going to set these two pieces equal to each other. We want the limit as x approaches 2 from the left of g of x, and that limit would be 2 squared minus 3 times 2. We want that to be equal to 5 times 2 plus k, which is the limit as x approaches 2 from the right. So I have this equation here in the middle, and notice k is my only variable, and so I can solve for k. Negative 2 is equal to 10 plus k, and k equals negative 12. And that's our answer. If k is equal to negative 12, then g will be a continuous function. In question number 2, we've got a function f of x, again a piecewise function, and we're asked to show that it is continuous at 5. Similar to the question we did before, the caveat is that we have to show, if we're going to prove that this function is continuous, we have to show that it satisfies all three parts of the definition of continuity. So let's start first with the value of the function at 5. If I look at my function, the equal to sign is included in the second piece. So to get my function value, I'm going to plug in 5 to that part of the function. And I have 5 halves minus 2, which would be 5 halves minus 4 halves, or 1 half. So I've got the function value, it exists. Now I need to find the limit and see if it exists. And if the limit exists, that means that the limit from the left, the limit as x approaches 5 from the left of g of x, would be equal to the limit from the right. And let's see, the limit from the left, if I plug in 5 to my first piece, I have sine of pi times 5 over 6, and I want that to be equal to the limit from the right, which would be 5 halves minus 2, plugging 5 into the second piece. And let's see if these two things are equal. Got this equation here in the middle, sine of 5 pi over 6, so that's a unit circle question there. Sine of pi over 6 is 1 half, and 5 pi over 6 is in the second quadrant where sine is positive. And so that does indeed equal 1 half. And 5 halves minus 2, we already figured out that that equals 1 half. And so therefore, the limit does exist. So the value of the function exists, the limit exists. And the third thing that we have to say, although it may seem obvious from our work here, but we need to state that the limit as x approaches 5 of g of x is equal to f of 5. The value of the function exists, the limit exists, and they are equal to each other.